Compound interest is one of the practical applications of exponential functions and using logarithms. There's two different formulas that we're going to work with, the regular compound interest formula and the continuous compounding. The continuous has the e in it, and you'll look for keywords in the application problems that'll clue you into which formula that you're going to use. So we're going to quickly outline the different parts of these formulas. A is going to be your final amount. Sometimes that's like PN or AN. Different letters can be used in these spots. P stands for principal, which is the amount that you invest into an account or an item. Amount invested. R is your interest rate. T is time in years. Now when we do other application problems, that's not always the case, but in compounding with money, it's always going to be in years. And N is your number of compounding periods. So we don't need this in the continuous compounding. Remember back to when we developed what E was, we kind of use a similar looking formula to that. So for compounding periods, if we're going to use that first formula, N equals 1 would be yearly, N equals 2 would be semi-annually. So if you think a semicircle is when you cut the circle in half, same thing, we're cutting the year in half with semi-annually. 4 would be quarterly. This is a popular way for people to talk about money in different quarters. N equals 12 would be monthly. And then 365, although this could be different, but we're going to use that as our standard for daily. So depending on which type of compounding period the problem talks about will depend on either the formula you use or one of these things. So this is a good page to kind of look back at as a reference for later on. We're just going to go through a bunch of examples. What you may want to do is just pause after each example, make sure everything you have in there is copied down, because we're going to go straight through on this video through all of them. Alright, our first one says find the amount that results from $2,000 invested at 4% compounded yearly. So we're going to use that first formula. A lot of information here that you can pull out, kind of underline. I like to sometimes write it out. You don't have to always do this, but we know that we're putting in $2,000. Our interest rate, we're going to change over into a decimal, so we're going to make it 0.04. And whenever you do that, you're really just dividing by 100. Because percent is out of 100. Our N is going to be 1, and our time is 5 years. So we are going to be using the first formula. If you write everything out in advance, then you plug it right in. And plugging this, you can really put this straight into your calculator. So you would put in 2,000 times 1 plus 0.04 to the 1 times 5. As long as your calculator is updated, this is a good way to do it. You can use things like alpha y equals if you do have a fraction that you're working with. Since we're going to be working with money, you're always going to round to 2 decimal places, and that will be standard throughout as long as the final answer is money. And we'll keep the other ones also 2 decimals. Our second example is going to be very similar, but it's going to be compounded continuously, so we're going to use a different formula. We are starting with $30,000. Invested at 3.5%, so our R is going to be 0.035. Our t is going to be 2. So we have less information that we're identifying here because there's less to plug into this formula. Good way to help you remember the formula is to think of the word, sorry about that, I just dropped my calculator cover. So think of the word PERT. There used to be a shampoo, that PERT Plus, a shampoo conditioner combination. It's not very popular anymore, so it's not a great way to remember it, but you can just remember the word PERT. I'm going to plug in everything. Use the E button on your calculator. So 3,000 times E to the 0.035 times 2. Do not use parentheses up in the exponent. You can just type it in times. Sometimes that causes problems, although now with the updated calculators it's a little bit better. And that is our final amount. This is the last one we're going to do where we're just typing it straight in the calculator before we start having to take the log or the natural log of both sides, which will take a little bit more work. So we're going to calculate the amount of money if you invest $1,300. So P is $1,300. Our rate is 0.046, and we're going to do this for 15 years, compounded monthly. So our N is going to be 12. We're going to use this formula. Now again, you're going to plug this right into your calculator. I would use the alpha y equals for the 0.046 divided by 12. And we're going to get a final answer here of $2,588.41. Now I did say we're going to do this video all in one shot, but we're going to actually stop here because these first couple of problems were ones that you were just plugging the value straight in. After this, we're going to be doing some log and natural log stuff, so that will be in the next video. It'll give you kind of a chance to take a break and digest this information.